Hey, so today what we're going to be showing is a application that I built for using active cache with GlassFish. It's one of the new features in GlassFish 3.1 and Coherence 3.7. So I'm going to go ahead and start with my IDE. I'm running NetBeans 7.0, which was recently released. And I'm going to show you the project that I've built and talk through some of the things you need to do to your web application to enable active cache for GlassFish. Then we're going to go about and actually build a GlassFish environment and set up mod.jk for load balancing on my local desktop here. And then we're going to start a standalone cache server and actually go about setting up the sample application. So first, this is a Maven-based project that I'm going to be using today. And the shopping cart web app, Maven web app, GF21, is the Maven module that is the web application. And so before we get too far into it, I thought it would be worthwhile just to show you a couple of the servlets that form the shopping cart application that we're going to be using today to illustrate the active cache for GlassFish feature set. So the first one is what we're going to call the View Shopping Cart servlet. And the sample application here is using servlet 2.3 type technology. So this is what you would expect to see in a either a legacy application or something you've built and are maintaining, or even in servlet 3.0 based applications. Now, this servlet actually is using a mixture of Coherence APIs as well as the active cache for GlassFish feature, which doesn't require you to make code changes. You simply enable some configuration settings and you can go from there. So what I'm going to show you is both the API usage and then the configuration changes that are part of active cache. So this View Shopping Cart servlet, what it's going to do is basically maintain the state, or I should say dump the state of the HTTP session runtime. And you can see that here where I'm iterating through a list of items in the HTTP session object. In addition to that, there's a couple of API calls that are unique here. One at the very top you'll see is the cache factory get cache, which is a Coherence specific API. So in addition to simply using HTTP sessions and pulling out a model object that's called shopping cart item, I'm also making a couple of named cache API calls. And what we're doing here is we're keeping track of the total amount of store interest. And so every time a member or a user adds a item to their shopping cart, we increase the count for a number of people interested in that item. And so we're maintaining the global state, if you will, of the item across users, independent of the actual HTTP session. So if you open the servlet called shopping cart, which is the servlet that gets invoked when a user adds, you'll see I'm also referring to this named cache here called store cache. And this time I'm using a entry processor to increment the attribute store interest of the shopping cart item instance in the named cache, okay, across all the instances. So what it's doing is it's going to invoke a new number incrementer, which will increment the number by 1 every time a user adds the item to the cart. Okay, so that sort of gives you some idea of what the actual application is going to do, and sort of what the code is behind the example that we're going to show. One other piece that's worth probably taking a deeper dive at is the actual project for the cache server itself. So I'm going to go ahead and drill into that. And for those of you who aren't familiar with Coherence, one of the things you'll note is that it typically especially in a Coherence-based application, you run a number of Java virtual machines we refer to as cache servers, which are the JVMs which are used to actually store the object data itself, as well as the processes through which entry processors get executed. So in this example, I'm providing a couple of shell scripts called start cache server.sh, which get macro replaced as part of my Maven build. And I do this in order to maintain consistent configuration across my web application as well as the standalone cache server. And you can see here, this is this shell script which we're going to use to start up the cache server will be used as well. So when I run the maven install command, effectively it will go and do a macro replacement against the property files. And the property file, and I was a bit lazy. Instead of using a settings XML, I've put the well-known address and port for Coherence. One of the mechanisms through which Coherence uses to identify members in the cluster is through what we refer to as a well-known address, or WKA. The well-known address is used to locate a known member in the cluster for providing membership. And in this case, I'm using my private address here, 192.168.78.1, and where we use this configuration for every process that we use to start the cluster, and it'll use this address to connect and find additional members. Okay. Now let's shift back to our web application and look at the changes that you need to make. Now, as we discussed in the slides earlier, and one of the things you do is to enable active cache for GlassFish is you go into your glassfish-web.xml file or your sun-web.xml file, and you need to configure the session configuration to use Coherence Web. And the way you do that is you create a set of elements. And I've used the Julia Childs approach. I've simply commented those out, and I'm going to just put them back in. So you can see it's pre-made. I have a session config parent element, and the child is session-manager. And you set the persistence type attribute equal to coherence-web. And so what this does, when you deploy this application, it's now going to try and load the Coherence classes as well as the active cache runtime environment. Okay, so I'm going to save this. And then the other step for enabling active cache for GlassFish and Coherence Web is to ensure that you've packaged the appropriate jar files. And because I'm using Maven, I've already installed these into my local repository. Again, using the Julia Childs approach, I'm just going to uncomment these. And you can see here I'm including the Coherence Web jar as well as the Oracle Coherence runtime jar. So this is using a web-scoped application deployment. Okay. Now that we've made all the application changes and the couple of bits we need to basically Coherence Web enable our application, is I'm going to rebuild the application using the Maven install command. So I'm going to switch over to the root project directory and run my Maven clean, just to clean out the old bits and do the install. And what this is going to do is rebuild the application using the configurations changes that I just made with you. And this will take a few seconds while the application is being built and packaged. And so once this is all done, I have a set of binaries, a war and ear, that I can now use to deploy to GlassFish as well as my standalone cache server, which we're going to start up shortly. Okay. So this is sort of the first step, is preparing your application. And now what we're going to do is build a GlassFish domain to host our application. And so I'm going to use, again, a Julia Childs-based approach. I've created a shell script that I use to recreate this called domain creation.sh. Instead of running it, I'm going to do it manually, but I'm going to copy and paste the commands out of here as we build the domain. So you'll see me toggling back and forth between my IDE and the command line. So the first thing we're going to do is run the asadmin, and I'm going to sort of increase the size of the font so that it's easier to see. And I'm going to run the asadmin command to create domain. And let's name this domain active cache. Whoops. I'm going to take the defaults, which is no password and the default port configurations, and I'm going to go ahead and wait a few seconds while the private public key pair for the SSL key store is generated. And in a few seconds, I should have a running domain. And then I'm going to configure the domain. Let's go ahead and use the console now. You can see the domain is now created on port 4848 where the admin listener is. And let's just go ahead and make sure it's started by running asadmin start domain active cache. Now I'm going to launch a web browser. I'm going to use Firefox, but you can use your favorite browser. And hopefully in a few seconds we'll have a running domain on port 4848. So I'm going to go ahead and log into my local host on port 48. Doesn't look like the domain's up and running yet, so I'll switch back here to make sure it's running. And it should be up, so let's go ahead and try again. And sure enough, the console is being activated. So now once the console comes up, I'm going to use the GlassFish server admin console that's part of the Oracle GlassFish server environment to create a new cluster to host my application. Now, Active Cache for GlassFish doesn't require a GlassFish cluster to be enabled, but we're going to use it as a mechanism for configuring multiple instances of GlassFish so that I don't have to reconfigure a bunch of standalone instances. So I'm going to do this by clicking on the cluster tab here. I'm going to go ahead and click New. And I'm going to create a new cluster. And I'm going to call it Active, well, we'll just call it My Cluster for simplicity. Oops, My Cluster. And I'm going to add a couple of instances, and we're going to make a copy here. Let's see, instance 1 with a weight of 50. Create another instance called instance 2. Okay. And we're going to leave the default radio button, which makes a copy of the default configuration and creates a new one called mycluster-default config, and you'll see that once I hit OK here. So what this is going to do is create the proper topology elements inside of the domain.xml. And once this is done, we can go now into the configuration that it's going to create for us called myClusterConfig and make the proper configuration changes. So we're going to add some JVM attributes, and these are mostly related to coherence. So I'm going to go to there by clicking on the JVM options. And you'll see this is sort of the standard JVM options that gets created from the default configuration. And I'm going to add a new one here. And so I'm going to talk you through by using my Julia Childs approach of sort of copying from my shell script here, but describing each one of these as I add them in. The first one is going to be the well-known address. And again, what we talked a bit about this earlier, but what this enables you to do is configure the well-known address to communicate with a known endpoint. And that is, in this case, I'm going to use the 192.168.78.1. The alternative to well-known addressing is multicast, but because I run a VPN from time to time and the VPN disables multicast traffic, I like to use well-known addressing because it's a sort of guaranteed operation to work. I'm going to add another JVM option, and we'll talk through this one as well. This one is distributed local storage. Now, if you remember from the lecture and the slideware, one of the things that Coherence does is, by default, we've storage disabled a couple of the distributed caches. And this is particularly for the store cache that is used to track the store interest object. So here what we're going to do is just add another JVM option as well. And this is going to be for session storage. And each one of these storage configurations is going to tell Coherence to use the standalone cache servers for storage and to disallow storage in the actual JVMs running Oracle GlassFish server. So now I'm going to switch back here and get the last one we need. And this is localhost. Because I have a multi-home machine, I'm going to need to tell Coherence which interface I want to bind to. In this case, I'm going to bind to the same address as my well-known. Because I'm running everything locally, you'll see that the address will be the same as the well-known address. 168. Now, Coherence using the auto ports. So each process that starts up, because we're going to bind to the same IP on the same host, it's going to create its own ports automatically for us and auto increment the ports. So we don't have to actually configure the port here. That's sort of built into the configuration in case folks are wondering about that one. I'm going to go ahead and save the configuration. And this basically stores it. Whoops, I had a error there. It does not start with -d. Okay. My parameters are messed up here. I think I made a typo there. Just do -d and go ahead and save that. Good. So now I've actually saved the configuration. I'm just going to validate that they're all there. So we should have several -d, Tangasol, Coherence, well-known address. We also should have our local storage enabled and our local host set. And it looks like we have all three of those values there, or four of them. So now, one thing we're going to do before we actually go about deploying the application is we're going to configure a modjk based load balancer using Apache and Apache modjk so that we can have a single endpoint communicate, or a single HTTP listener communicate with our GlassFish cluster here before we deploy the application. So what I'm going to do is I'm going to go and switch back and enable modjk, and I have a separate shell here, and so I'm going to show you a couple of configurations. First, I'm going to show you my modjk configuration file. This is using my built-in Apache that's part of my Mac OS X operating system. You'll see here I'm pointing to a JK. Well, first thing I'm going to do is load the modjk file. Then I'm going to point to a properties file that contains the configuration that I'm going to use. And then you'll see the most important bit here is using jkmount command to mount my context path to a logical name that will be defined in the worker's property. So I'm mounting all requests to shopping cart or shopping-cart to the named load balancer. And so now let's go look at the worker properties file here, so you can see that the worker list is going to contain worker 1 and worker 2, and those are on the ports for 28080, which is the default port for instance 1, and instance 2 is going to be on 2881 for worker 2. And then the load balancer is basically, you'll see sort of the last line here, worker.loadbalancer.balance_workers between worker 1 and worker 2. So this is going to enable this load balance configuration to balance between those two ports. Okay, so I'm going to quit out of there. And then this, of course, the modjk file is referenced inside of my httpd.conf file. I won't show you that, but I promise you it's there. Now, there's a couple of configurations we have to do on the GlassFish side to enable modjk, and this is all covered in the documentation, but just for completeness, I'm going to go ahead and show you what it looks like. So again, using my Julia Childs-based approach, I'm going to switch back to NetBeans and copy out the configuration elements here. The first is you have to have a -d JVM route. And this points to the route that you want the worker to use for load balancing. In this case, it's named load balancer. So we're going to go back here. I'm going to add a new JVM option called -d. JVM route is the load balancer. Okay. I'm going to add another one, and going back here, I'm going to copy that one over. And this is where the workers.properties file is. In this case, I'm referring to it. It's on the same machine. If I were using a Apache instance that was on a different machine, I would actually have to copy the file over. And this is using the -d ComSun enterprise web container enabled jk.property file. And this literally just points to the workers.property file that we've used in the Apache configuration as well. Okay, so I'm going to just copy that in and paste that in, and I'm going to hit save again. And you should see I have some new values saved. So my configuration's been saved, and now there's just one more step. So now let's go and look at the actual network configuration. And what we have to do to enable modjk is set the network listeners to listen for AJP traffic, or the Apache Java protocol, as opposed to just the HTTP traffic. So I'm going to go ahead and click JK listener under the network config, network listeners, HTTP listener -1. and this is the referenced by the myCluster config. And so in there, the Grizzly listeners for GlassFish server are going to use this configuration. Okay, so I'm going to go ahead and save this. Now, I think we've pretty much finished our configuration for GlassFish. Now we're going to bring up the cluster. So I'm going to go back to the cluster node here, and I'm going to go ahead and click on the myCluster, and I'm going to go ahead and start the cluster up. Now, once the cluster started, we can actually go about deploying the application. But before we do that, one of the things we're going to want to do, because we're using an external cache server for storing the HTTP session data as well as the store interest cache, what we're going to do is we're going to need to bring up our standalone cache server. So I'm going to go back, and I should do this shell script very early on in this demo. So I'm going to go ahead and switch back to my Maven environment, and I'm going to cd into the shopping cart cache server project. And there's a subdirectory in here called, let's see, it's called cache server underscore server. And there should be a bin directory, and I'm actually just going to run my shell command here, which is going to bring up the standalone cache server. And you can see from the output, this is what a cache server looks like. You can see I'm using 3.7, and the cache server basically didn't find any additional members, and it simply brought up or created a new cluster, and it's waiting for requests to the data grid in addition to any additional members to join. Okay. Now let's switch back to the console. It looks like we have our cluster instances are now running. So now we're ready to actually deploy them. So let's go ahead and deploy the application to the myCluster. I'm going to click on myCluster and go to Applications. And let's go to the Deploy Application button. And I'm going to actually browse to the file here. And let's see where I am. I'll make sure we're in the right place here. Okay. Cart ear, target. I'm just going to bring up the whole ear file here. And make sure it's selected to the target myCluster. Okay. Want availability enabled, and I think we're all set. I'm just going to check this real quick. And availability enabled just ensures that the session propagation is enabled. So I'm going to go ahead and hit processing, which is going to deploy the application to the cluster. Now I'm going to switch back to the console here, and you're going to see once the application is deployed and the application is started, they're going to join the cluster, and we'll see this output in the standalone cache server. And that'll give me a pretty good indication that the application is successfully deployed. So here you can actually see it. Now the members are joining, and I suspect our deployment, I can see members 2 and 3 are now there. So great. So now let's go about and actually test the deployment. But before we do that, I'm just going to restart Apache real quick, just to make sure that the Apache load balancer is actually the configuration that it's set up properly here, or taken my latest config changes rather. Okay, so now Apache's listening on port 80, so it should have my /shopping cart, the new tab. And go this time to port 80, localhost, shopping cart welcome.jsp. And this should be the home page. And sure enough, there we are. Let's go shopping this time. Now what I'm going to do is I'm going to add a few items to my shopping cart. Let's start off with a box of 12 pens. And this is going to add a number of items to the HTTP session. Let's add a box of pens blue this time. And then how about a package of 500 paper? Okay. Now let's actually view our shopping cart. So you can see I have a box of 12 pens, package 500, multi-purpose paper. Now what I'm going to do is I'm going to actually go ahead and stop the GlassFish cluster altogether. So let's go back here and to our asadmin command, and we're going to shut down the entire cluster. Stop cluster, myCluster. And what we're going to see is that independent of the HTTP session data, everything is being stored on the storage enabled cache member. So all the state is being pushed to a second process, which is still running. You'll see now, I'll just prove to you. So I'm going to refresh this here and go back to my shopping page. And you'll see the service is temporarily disabled. I'm going to go ahead and start the cluster here. So you can see that every member in the cluster is currently down. We're going to restart the cluster, and I'm going to toggle back here, and you should see the members rejoin. As soon as the cluster is back up and running. Now our state's going to be completely maintained in the storage enabled cache member. So you can see how the lifecycle of the GlassFish server is completely independent of the storage enablement of the actual state information itself. And so we should see those come back up, make sure the cluster command's still running. And in a few seconds, you'll see them rejoin the cluster, and you'll see my HTTP session data is all maintained without having any GlassFish member running in the cluster. So now I can see a couple of new members have joined, which is the cluster started. Let's go ahead and refresh the page here. Let's go back home and look at our shopping cart. And sure enough, see, our session data is still there. All the state was maintained, including the total numbers sold on Disney World. I can go back to the shopping page here and add more data, and sure enough, my application's still running and the user's none the wiser, right? So this is one of the key neat things of the active cache feature set. In addition, of course, obviously you can store more transactional information on the heap in the application server, and you no longer need to store for HTTP session data. All right, excellent. Thanks for watching.